7.2, practice A. We're going to look at numbers 20 through 23. In exercises 20 and 21, use the diagram and the following information. The distances between the three towns are given in the diagram. So A, B, and C are towns. Is the triangle ABC, formed by the three towns a right triangle? So you have three lengths. Does it make a right triangle? Yeah, I'm going to look at this and I'm going to say 5, 12, 13. That's a triple of 5, 12, 13. You multiply them all by 3, you get 15, 36, 39. That's how I'm doing it. Yes, it's a right triangle. Now, since you're able to see my calculator here, I will show you the work in case you don't get the whole triples thing. 15 and 36 would be your legs if it's a right triangle, and 39 would be your hypotenuse if it's a right triangle. See how these numbers match? That's how you know it's a right triangle. Number 21. So yes, this is a right angle. Town B is directly west of Town C. Is Town A directly north of Town C? Well, if this is directly west, then this is directly north because north and west are separated by a right angle. So that's true, yes. If that was not a right angle, then the answer would be no. In exercises 22 and 23, you will use two different methods for determining whether triangle ABC is a right triangle. Here's your first method. Find the slope of segment AB. We can do that by counting. I'm going to count up 2 units, and I'm going to count to the right 4 units. So the slope there is up 2, right 4, which is 1/2. Find the slope of segment BC. So I'm going to count down. 1, 2, 3, 4 units. And I'm going to count to the right 2. Since I'm going down, it would be negative 4 over 2, which is the same thing as negative 2 over 1. Notice these slopes, positive 1/2, negative 2 over 1. These are opposite reciprocals. Is it a right triangle? Well, these two segments come together at this angle. It must be a right angle because of the opposite reciprocal slopes. Those were perpendicular. So you know it's a right triangle. Now here's the other way you could have done it. That was pretty easy, just counting using slope. But here's the other way that kind of uses the skills from this section. Use the distance formula and the converse of the Pythagorean theorem to determine whether triangle ABC is a right triangle. So in other words, how long is this? You can't count it. You need to use the distance formula. Subtract your x's, subtract your y's, square them, add them, take the square root. How far is it from point B to point C? Use the distance formula. How far is it from point A to point C? Use the distance formula. Okay, now you could type this into your calculator. I'm kind of afraid that it's going to give you a decimal. So I will type it in. We'll see what we end up with here. And if it gives us a decimal, we can adjust. 4 minus 0 squared. Notice I'm just typing this guy in. I'm going to insert a parenthesis there. Plus, and then we'll do 2 minus 0 squared. Yeah, so that's what I was afraid of. It gives us a decimal, which isn't really what we want because we're going to take this answer and then use it to find something else. Okay, so maybe writing your answer in simplest radical form is best, which is why we learned those skills too. So if I just do this, I'm going to get that same exact thing. Actually, I could have done something else too. But if I just delete that square root, notice how that gives me this. So what that means is your radicand is 20. And I know that's not simplified radically, but you can leave it like that for now. Let's do the same thing for distance from B to C. If I type in that radical, it's going to give me a decimal again, so maybe I won't do that. And again, it's going to give me a radicand of 20, so it's square root of 20. And then, how far is it from A to C? Oh, you're not even seeing my calculator. Now, do these segment lengths make a right triangle? So in other words, they're asking you the square root of 20 squared plus the square root of 20 squared. Does that equal the square root of 40 squared? And that might look really, really confusing, and it might be really tricky to type in the calculator, but think about what you're doing. If you take the square root of 20 times the square root of 20, the radicals cancel, and what you get is your radicand. The square root of 20 squared is just 20. The square root of 20 squared is just 20. The square root of 40 squared is 40. 20 plus 20 equals 40. Definitely, it's a right triangle.